Hello everyone. So here we have problem number 16 from chapter 7 and 8, week 2, physics 2. Consider a parallel plate capacitor with distance between the plate of 1 centimeter. It contains 9.4 millimeter thick dielectric layer with constant of 110. Adjacent to one of the plates, the capacitor is charged to 45 volts. The charged capacitor is first unplugged from the power source, and then the electric layers are pulled out. What will be potential difference between the plates of the capacitor? Okay, so let's write down all the given values. So before writing down, let's draw the diagram. Okay, so suppose this is a, so we are looking on from the side view. Okay, so this is the capacitor. Distance between the capacitor is, let's say, D. Okay, so D here is equal to the 1 centimeter. So let's take it as a 10 millimeters. Okay, D. Then 9.4 millimeters. So say that 9.4 millimeters. So this is D1, which is the 9.5 millimeters. So D1 is equal 9.4 millimeters. Okay, and definitely it has K constant, dielectric constant. Then what else? We also know that we have this D distance. So this D distance, D1, so let's write down here K1, which is 110. Then we have D2, okay? So D2 here will be D minus D1, which should give you 0.6 millimeters, okay? 0.6 millimeters. So we have to find, so initially it is charge potential difference across the capacitor. So let's say initial the voltage across the capacitor VC initial is equal to the 45 volts. Okay, now in the second scenario, what will happen is that in the second scenario, what will be the potential difference across the capacitor when dielectric has been removed? Okay, when D is just equal to the 10 millimeter, what will be the, so K here is equal to 1 because it's it filled with A. Okay, when K1 is removed, what will be the new potential difference? So VC final, what is the VC final when K1 is removed? Okay, so how can we find it? The first of all, let's look at the formula of the capacitor. Okay, the general formula of the capacitor when we have dielectric on it is defined as C is equal, K is a constant, epsilon naught area of the capacitor divided by a distance. Okay, this is a formula which can be used now. If we look at here, this one since it can be considered as a two capacitors, you can do it like this one. So this is the capacitor. It can be resolved into two capacitors because one is filled with air and as one is filled with a certain dielectric. So suppose that will be the C1. So this is, let's say, C1. This is C2. Okay, this is air and C2 is dielectric. So let me just fill it with dielectric. Okay, so if that's the case, then we can see that the capacitors are connected in series. Okay, if they're connected in series, then what will be the formula of, so what will be the total equivalent capacitor in this case? In this case, when C equivalent can be found when they're connected in series, so what will be? The formula is defined as a C equivalent is equal to the C1 times C2 divided, so C1 times C2 divided by C1 plus C2, okay? When the capacitors are connected in series, it will be defined in this equation. Now, let's write down what is the C1 and what is C2. So the C1, since there is it's filled with dielectric constant, so we can write down K1, okay, epsilon naught area of the capacitor divided by the D1, okay. So what about D2? D2, which is this distance, which is filled by the air. So definitely we can write down as a K2, which is air, which is equal to 1, but we don't need it. So therefore we can write down that C2 is equal, is filled with air, so it's equal to 1, dielectric constant. So we can just write it down epsilon naught area divided by the D2. Okay, so let's plug those things here. And C equivalent is C1 is equal K1 epsilon naught area divided by D1 plus epsilon naught area divided by D2 divided by K1 epsilon naught area divided by D1 plus epsilon naught area divided by D2. Okay. After doing calculations, what we got? We will get here K1 epsilon squared area squared divided by D1 times D2, and this one will be D2 K1 epsilon naught area plus D1 epsilon naught area divided by D1 times D2. So this will cancel out. So at the end, this thing with epsilon naught area will cancel with one of them, and you will end up with formula of K epsilon naught area divided by the K D2 plus D1. Okay, this is your equivalent capacitance when there is dielectric. Now, what will be the charge there? So the charge initially in the capacitor when there is dielectric is defined as a C equivalent multiplied to the voltage across the capacitor, okay, which is initially, okay, also. So that means we have what? We have K epsilon naught area divided by K D2 plus D1 multiplied initial voltage. So let's do calculation. If we do calculate, K is equal to 110, correct? 110 multiplied epsilon, we don't know, we can keep it as it is. Area, we don't know, divided to the K is 110. D2 was what? D2 was 0.6 millimeters, correct? 0.6 millimeters or 10 to the power of minus 3 plus D1 was 9.4 millimeters. 9.4 millimeters, which is 10 to the power of minus 3. Now, if we do calculate it, we will end up equivalent. So we're trying to find the charge. If we do calculate it, we will end up with Q initial is equal epsilon naught A area. Let's keep it like this one, multiplied to the 65,649. Okay. So this is our initial charge when we have dielectric in the capacitor. Okay. Now we have to find what will be the voltage when we will remove this dielectric K2 in the capacitor. What will be? So we know that C new capacitor is defined as since we will remove dielectric, so that means epsilon naught area divided by a D. D means total distance of the capacitor, okay, which is this one, which is equal to 10 millimeter, correct? So that's if that's the case, then to define the new voltage, so V new, or in other words V final, when we remove it, so it will be Q initial divided by the C new, okay, or final, okay? So that means we can say that Q new is, so V final or new is equal to the Q initial, which is epsilon naught area times 65,649 divided by C new will be what? C new is equal to the epsilon naught area divided by the D. D is 10 millimeter, correct? So is it 10 millimeter? So let me look at it. 10 millimeter, yeah, D is 10 millimeter, which is 10 times to the power of minus 3 in terms of the meter. So this will cancel out. So the final answer, it will be, so it goes there, 6.49 volts. This is your final answer.